DuPont's Tonawanda facility manufactures a polymer known as Tedlar, used in solar panels, and Corian for use in countertops. The process of producing Tedlar began with a chemical reaction to convert flammable vinyl fluoride gas into a slurry of polyvinyl fluoride polymer, or PVF, in water. The PVF slurry then passed through separators. Compressors recycled unreacted vinyl fluoride gas into the process, while a small flash tank released residual vinyl fluoride into the atmosphere. Finally, the slurry was transferred to one of 3 insulated holding tanks, usually tank number 3. Tanks 1 and 2 were reserved for slurry overflow. Tank 1 normally remained empty. On October 22, 2010, the Tedlar process underwent a planned shutdown, during which workers removed the asbestos insulation on tanks 1 and 2. Removing the insulation revealed that the agitator supports for the tanks were heavily corroded. DuPont directed contractors to repair the supports, which would involve welding and grinding on tanks 1 and 2. The hot work on tank 2 occurred during the shutdown without incident, but the repairs on tank 1 were delayed while parts were ordered. DuPont personnel determined that it would be safe to perform hot work on tank 1 after the restart. On November 7th, DuPont operators locked all 5 valves leading to and from tank 1 in the closed position in order to stop potential slurry flow. The tank's agitator motor was also locked out. However, DuPont personnel did not block the flow of gas inside the overhead piping, or overflow line, that connected the vapor space of all 3 tanks. They mistakenly believed that flammable vinyl fluoride gas could not reach any of the slurry tanks. But the CSB investigation found that even in normal operations, vinyl fluoride was not completely removed from the slurry and was always present in the slurry tanks in varying amounts. When the process restarted on November 6th, the flammable gas was able to travel from tanks 2 and 3 through the open overflow line into tank 1. On the morning of November 9th, a DuPont technician tested the atmosphere above tank 1, where welding would later take place. There were also 2 continuous air monitors in the vicinity. No flammable gas was detected, and the hot work was cleared to begin. But no testing was done to measure or monitor the atmosphere inside the tanks, where, unknown to the contractors, the flammable gas was at dangerous levels. Around 9 a.m., 2 contract workers began welding and grinding on tank 1. The welder connected his safety harness to the tank's agitator support and worked on top of the tank as the foreman looked on from the nearby catwalk. At approximately 11 a.m., the welder was repairing corroded portions of the agitator support beams directly above the flammable gas. A hole around the agitator shaft may have provided a pathway for ignition. Welding sparks could fall into the tank, even as flammable gas might drift upward toward the sparks. The ignition of the vinyl fluoride caused a powerful explosion. The force of the blast blew the top of the tank almost completely off. A flash fire erupted that consumed the flammable gas and quickly burned out. Its corporate policies to require atmospheric monitoring inside tanks before and during any hot work. And the board recommended that DuPont require all process piping, including vent lines on tanks, to be positively isolated before authorizing any hot work. The CSB said companies can prevent hot work accidents by analyzing the hazards, enforcing rigorous training and permitting procedures, constantly monitoring the atmosphere for flammables, and avoiding hot work in favor of non-spark producing methods whenever possible.